In this video, we're going to look at 4 examples that will let us practice classifying angles. In example A, it says, name the angle and determine what type of angle it is. So to name an angle, remember you can use either 1 letter or 3 letters, although sometimes you actually have to use 3 letters. If using 1 letter, it would be ambiguous. In this case, we can use 1 or 3 letters. So we could call it angle U, or angle TUV, or actually we could also call it VUT. If you're using 3 letters, just make sure that U is your middle letter since that's the vertex. Now when it says what type of angle is it, it's asking, is it acute, is it obtuse, or is it perhaps a right angle or a straight angle? So in this case, we could use a protractor to find out for sure, but I think I can tell just by looking that it has to be obtuse. The way I figure it out is look and sketch in my head what a 90-degree angle would be. So from UV, this would be a 90-degree angle. So since TUV is bigger than the 90-degree angle, it has to be obtuse. All right, let's look at example B. Example B says what type of angle is a 165-degree angle? So here is really just a memorization of the vocabulary. You have to know that any angle that is bigger than 90 degrees but less than 180 degrees is going to be obtuse. So because 165 degrees is bigger than 90 degrees or greater than 90 degrees, it is an obtuse angle. Okay, and example C, what type of angle is 84 degrees? Well, 84 degrees is less than 90 degrees, and an angle that's between 0 and 90 degrees is an acute angle. So this is an acute angle. And for obtuse, acute, and right, and straight, those are all just words you really have to remember and should remember because they'll come up a lot throughout the whole year of geometry. And finally, example D. Draw an example of a right angle. How do you know it's a right angle? So now we can see that we're looking at a grid, and a right angle is created by perpendicular lines. So we have to remember some algebra in order to think about how can we create perpendicular lines in a coordinate plane. Now perhaps the easy way out would be to follow the grid lines and draw an angle like this. This is clearly a 90-degree angle because it makes that square corner. So this is a right angle. Now what about if you wanted to make one that was more off-center or didn't line up with those grid lines quite as exactly? You should remember that right angles, which are created by perpendicular lines, have to have lines with opposite reciprocal slopes. So that's what creates perpendicular lines. And we're not going to go into every detail of algebra right here, but we'll just do one example. So say we had this was one of our line segments or line rays, and we're trying to figure out where should the other ray go to make it be a right angle. So this line right here has a slope of -2 because we go over 1 and down 2. So the slope is -2. A -2 opposite reciprocal of that would be positive, that's the opposite part, 1/2, so you flip the fraction. So to create the perpendicular line, we'd have to start at this point and make a line that has a slope of 1/2. So over 2, up 1, just like this. So this would be another right angle. So that's an important thing to remember from algebra in case you're working with problems on the coordinate plane. To test for sure if it's a right angle, the slopes have to be opposite reciprocals. All right, right now, hopefully you're feeling pretty confident with classifying angles.